Hey everybody, Mr. Mack here. In today's video, we are going to look at our review here for volume and surface area, sections 111 and 112. And so I've got our basic equations here for square, rectangle, circle, and triangle for the area and perimeter. And we can reference these in building our equations for volume and surface area of these prisms and cylinders that we are going to be looking at. So let's start off with number one here. Given the rectangular prism to the right, what is the volume, what is the surface area? So for volume, we know that V equals the area of the base. So I'm going to call this area sub B. We could also call this the footprint, the area of the footprint, times the height of the prism. Okay, so I've got volume equals area times height, and for a rectangular prism, the area of the base is length times width. So length times width times height is our volume equation, and why don't we just label the height, the length, and the width. So I could call 7 centimeters, that looks like my height of the prism, 5 is my length, and 3 is my width. And so I'm just going to substitute these values in here. 5 centimeters times 3. Now I'm writing my units in for this. We don't have to do this, but I want to make a point to show you that our units, when we do centimeters times centimeters times centimeters, that will give us centimeters cubed. Definitely want to include the unit here. And then 5 times 3 times 7, let's see, so 3 times 7 is 21, times 5, we get 105. So 105 cubic centimeters is our volume. Okay? So that part is done. I have shown the equation, I've shown the steps, and I've included the units. So I did all of these parts right here in the directions. So that's for part A. For part B, we are looking for the surface area. So surface area, I'm going to call this SA, for a rectangular prism is the area of all 6 sides added together. So we have 2 length times width areas. So if you could see, I've got, is that going to work if I do that? Nope. No, not quite. Okay. So I've got this base right here is my length times width, and the top face here is also length times width. So I have 2 of those, plus I have 2 width times heights. So if I look at this face right here, this is a width and a height dimension, same as this back side. So I've got 2 of those. So let's write width times height. Plus, now I've got this right side and this back side face right here. So this face right here, this is a length and height, and this back side's also length and height. And plus 2 length times height. And I already defined my variables, so now I can just substitute that in. So I've got 2, 5 times 3. I'm not going to include my unit this time. 5 times 3 plus 2 times width and height, that would be 3 times 7. 2 times length and height, that is 5 times 7. Okay, so I think I could do these individual parts. I think I'm just going to put it on the calculator. Well, let's see, 5 times 3, 15, that's 30, 21's 42, 30 plus 42 plus 35 times 2 is 70, 142. So the surface area of this shape is 142. Now, we're going to do all these units. We're doing centimeters times centimeters. So our unit's going to be centimeters squared for surface area. Okay? Now, I want to point out here that we could have made a net for this. Right? So we've got, if I make a net here, let's see, let's get the rectangular shape. So I've got, that's my base, the 3x5, and then that's the back, the front, and the right and left side here, and then I got to put the top on it. Right, so we get 6 sides, and I could find the areas of each individual rectangle and add them all up. So the 5x3, 5x7, and this one would be 7x3, and I could come up with the same thing. Once we understand how the surface area works with the rectangular prism, I like just to rely on the understanding of the equation, but we always can work through the problem with the net. And we'll do the same with the cylinder here. We've got a cylinder with a circumference of 9 pi and a height of 8 inches. And let's get the drawing over here so we can see. Okay, so what is the volume? So we're going to start off with the volume. V equals, as we did before, we know that the area of the base times the height is our basic general equation for volume. And the area of this base shape, what is this shape right here for a cylinder? It's a circle, right? So the area equation for a circle is pi r squared. Okay. So I got pi r squared times h. All right, so what is my r and what is my h? Well, my h is 8, and my r we don't directly know. But we are given the circumference is 9 pi. Okay, inches. And we know that the circumference of a circle is 2 pi r. 2 pi r. So if I write that equation, C equals 2 pi r, and I know my circumference is 9 pi, I could substitute that in for C here and solve for r. Now we're solving for r here. I want to undo multiply the 2 pi here. So what do I do to undo multiply? I divide. So I'm going to divide 2 pi to both sides. And we get, so pi's all cancel, and 9 divided by 2 is 4.5 inches. Okay, so my radius here, this radius, is 4.5 inches. Now I'm ready to put it into my equation. V equals pi times 4.5 squared times height, which is 8. And what did I say in the instructions? Round to the nearest tenth. Okay, so I'm going to put this in the calculator. And I recommend you do it. Learn how to use the calculator and don't just rely on me doing the calculation for you. 508.9. And the units, I think they're in inches, right? So volume would be inches cubed. Okay, there's our solution for volume. Next, we're going to take a look at surface area. So for surface area, I'll make a net for this. I think you can memorize the equation for the surface area of a cylinder, but we can derive the equation here from the net. So I'll just do it this time. So we've got a net would look like a division symbol. It's not a good circle. Here we go. We know our radius right here is 4.5 because we solved it from the previous problem, inches. And we know the height of this cylinder would be the same as the width of this rectangle. So this is going to be 8 inches. This is our height. And this length right here, which we would want to know. Okay, so let's just write the equation here. So we've got surface area, I'm going to call it SA. We've got two circles. How about I do this? I got 2 circles and 1 rectangle. Okay, and the area equation for a circle is pi r squared. We just saw that earlier. Plus, and the area equation for a rectangle is length times width. Now, the length and the width are the same as the height of the cylinder and this length right here. So this length of the rectangle is going to wrap around our circle here, right? When we enclose this shape. So this is the same as the circumference of the circle. Okay, same as the circumference. And what is circumference? C equals 2 pi r. So now I'm going to write surface area equals 2 pi r squared, that's my 2 circles, plus, instead of L, I'm going to write 2 pi r, because that's the same as the circumference of the circle, times, instead of W, I'm going to write H. Okay, so here's the equation. And now we just substitute 2 pi times 4.5 squared plus 2 pi times 4.5 times 8. Okay? And now I'm going to go to the calculator, and we're going to round this nearest 100. Are we doing 100th or 10th? What did I say here? 10th, right. Okay, so 2 pi 4.5 squared plus 2 pi times 4.5 times 8. $353.4. inches squared. Okay? That's my solution. Okay, so surface area is done. Got volume and surface area. Okay, next problem. Find the volume of the oblique prism below given the dimensions leave in terms of pi. So oblique means not right angle. This angle right here is not a right angle. Okay, it's not 90 degrees. And so I mean, this almost looks like a stack of coins, right? Can you imagine that I have a stack of quarters here? I'm making the ridges here of the quarters. And if I had this stack straight vertically, right, and I could find the volume, it would be the same as the equation that we just did before, where this is the height, the vertical height, 90 degrees from the base here. If I were to push the stack of quarters this way, so it's now at this angle, that does not change the volume that the quarters take up. It still would take up the same amount of space. It doesn't matter how I move or push the quarters around. So think about this as we determine what our dimensions are for this oblique cylinder. So the equation pi r squared h is our volume. And we want to identify r. Well, r we got right here is 3. So this is the 3 feet. And the height is going to be the vertical distance from the ground to the top of our shape, which is 4 feet. This is the height. The 5 here we do not use. This is just extra piece of information here to confuse you. So V equals pi times r squared times 4. Now this says leave in terms of pi, so that means we're not multiplying through by pi on our calculator, and we're just going to leave it in the answer. So let's just simplify this part. 3 squared is 9. 9 times 4 is 36, so I'm going to write 36 pi, 36 pi, and then our units would be feet cubed. All right, there's our volume. And that's it, okay? So we just have to recognize that the height is the vertical height, is not the slant height that we use for an oblique object. All right, I hope that was pretty easy. Didn't have to do so much work on that one. This last one here, we will. A rectangular prism with a volume of 432 cubic inches. So we have a volume. Let's see, what's a good color? Let's go back to midnight. So our volume is 432 cubic inches. It has a length, width, and height given to the right. Okay, so the length is x plus 1 meters. The height is 6 meters, and the width is x. So maybe I'll rewrite it. Length is x plus 1. The width is x, and the height is 6. And this is all going to be in meters. Okay, what is the surface area? Set equation, write the equation standard form, factor. Okay, we're going to have to factor this thing. Find the surface area and check. Okay. So our surface area equation, I'm going to put this right here, is the same as we used on number 2 above. We have 2 length times width. We have 2 length times height, and we have 2 width times height. We can make a net if you need to see all that, but I'm just going to do the simple equation right here. The issue here is, in order to find surface area, we need to know all 3 dimensions, and we only know the height. Length and width are all in terms of x. So we need to work backwards a little bit. We need to take the volume that we know given in the problem and see if we can write a volume equation with these dimensions and solve for x, which is what we're going to do. So volume is length times width times height for a rectangular prism. 432 is our volume. I'm going to put it in here. My length is x plus 1. My width is x, and my height is 6. Okay, I've set up an equation. So I've done that part. Write in standard form. So standard form is, I'll write it right here. Standard form is ax squared plus bx plus c equals 0. This is the standard form for a quadratic. We need to make this into that. So first, we have to do a little work on this right side. I could multiply through everything by x and 6, but I think what I'm going to do first is I'm going to divide both sides by 6, because I think 6 goes into 432, and it does. 432 divided by 6 is 72. Okay, and now I have x plus 1 times x. Next step is we need to distribute this x here into this binomial. So x times x is x squared, x times 1 is x, and I still have the 72 over here. Okay, now I need to subtract 72 to both sides. And now I get x squared plus x minus 72. And I could write 0 over here in the left, but I'm just going to switch it over here to the right. And now I've put this in standard form. Okay? So check on part B. We've done that. Now it's time to factor. Okay, so does this trinomial factor? So my a value here is 1. My b value here is 1. My c value is negative 72. So I want to find what are the factors. So we're thinking, okay, this is going to break it up. Two binomials here. It's going to be x and x. I need to find the factors of negative 72 that add to 1. So the factors, let's see. So the factors of negative 72 that add to 1. So 72, we've got 72 and negative 1. That doesn't add to 1. How about 36 and negative 2? That doesn't work either. We got 72 is divisible by 3. It'd be 24 and negative 3. That doesn't work either. And so as we go, I hope you see that the answer is going to be 9 and negative 8. Okay, there's a bunch of factors of negative 72, but because they add to 1, that means the two numbers are only one apart from each other, and one of them's got to be negative. 9 and 8 make 72, but if we make 8 negative and add, we get 1. So this works. Our factors are negative 8 and 9, so I'm going to put them in here. I'm going to put plus 9 and x minus 8. And now what we do is we use the multiplicative property 0. We know anything times 0 is 0. So what makes x plus 9 0? So I can just set it equal to 0. What makes x minus 8 0? And when we solve for these, I hope you see we get negative 9 and positive 8. Okay, so I'm thinking, okay, if I put negative 9 in here for x, I get a negative amount of meters for this side, and that doesn't make any sense. So I'm going to throw that negative out right here, and I'm going to keep the 8. So let's put 8 in here for x. So that means that the width is 8, and that means the length is 9. And these are all in meters. Okay, so I might put my units here. Okay, I use the volume equation to help me find x, and now that I know x, I know all of my dimensions. Therefore, I can find my surface area, because that was the original question. What is the surface area? 2 times 9 times 8 plus 2 times 9 times 6 plus 2 times 8 times 6. Okay? as we discussed before. All right, so I'm going to go to my calculator and put all this in. And just double check, 296, 286, 348. So I get 348 meters squared is my surface area. Okay, I hope that makes sense. That last one we had to do a little bit more work with factoring. And as you see, they progressively get a little bit harder using some more complicated topics. I don't know if I want to call it complicated, but just slightly more texture on each one of those. All right, I hope that makes sense. Check y'all later.